Before we move forward, more learning about the periodic table, we're going to discuss Coulomb's law, which we will do an activity in class to help us understand this better. But this law relates to the periodic trends we'll talk about on the next video. So Coulombic attraction is the attraction between oppositely charged particles. So when we have the protons in the nucleus of an atom, those protons are attracted to the electrons because remember, opposites attract. Just like with a magnet, opposite sides attract, the protons will be attracted to the electrons. This is not in your notes, but Coulomb's law will quantify the amount of electrostatic force that two charged objects exert on each other. And so repulsion happens when they have the same charge, like the top two, and the attraction happens when, so A for attraction happens when they're oppositely charged, and R for repulsion when they're not, when they're the same charge. So the farther away, there's two ways that govern this law. The farther away the particles are from each other, the weaker the attraction is between them, and the number of protons also changes, where more protons makes a stronger attraction. Okay, so I have these four elements. These are all in the same row on the periodic table, which is important. So this is Li. It just doesn't have that center circle. So the inner circle for all the other ones would be the nucleus. And then the rings on the outside are the shells or the sublevels where the electrons are located. Okay, and so I picked these four because all of them have two circles or two levels where the electrons are located. Okay, so lithium, beryllium, boron, and carbon. They go in order of the periodic table. So the first governing law or rule we had was that the farther away from the nucleus the particles are, then the farther away the particles are, the weaker the attraction. So we'll just assume that the nucleus is on the inside of these circles, just like how lithium has that nucleus there. Okay, so that is telling me that the electron on the first row is more strongly held. There's a greater force than the one in the second circle because there's a longer distance for the electrons in that outer circle. Okay, so we talked about energy levels in chapter 5. So the first circle would be when n equals 1, the first energy level, and then the second would be when n equals 2. So the stronger, I'm going to write it on boron just so that you can see it better. There will be stronger attraction for the first energy level and then a weaker attraction for the second, because as you get farther away, the attraction gets less, is weaker. Okay. Then the other rule we said was the number of protons, more protons equals greater attraction. And this happens, they're not exclusive. There's one, it talks about distance, and one talks about protons. So the protons, they have to be in the same row in order for this to apply. And we'll see that in our activity that we do. But since these are in the same row, we know lithium has 3 protons and 3 electrons because it has an atomic number of 3. Beryllium has 4, atomic number of 4, so it's 4 of each. Boron has 5, and then carbon has 6. Okay, so, and the reason why this works when they're in the same row is because of that distance on the outer circle not changing. The outer shell does not change. Since that distance remains the same, then the pole is from the same distance, so that's why when you have more protons, they're able to hold onto those electrons better. So that means that carbon will have a harder time losing its 4 electrons on the outside circle because it has 6 protons, versus lithium on its outer circle has 1 and has 3 protons. It'll be a lot easier for lithium to lose that electron. And we'll get into that more about losing electrons next video.